Okay, thank you. Yeah, it was an interesting talk, Don. We were just talking about the idea of inviting you back up as a guest panelist, so talk about mesh networks. But I was asked kind of at the last minute to moderate this panel since the moderator was not able to make it. So I'm winging it a little bit here, but it's a topic I find very interesting about new network topologies for submarine networks. So we have a good panel here that represent a variety of viewpoints. Some people that are doing cables that are very high capacity, so we kind of call them fat cables in the industry, and some that are working lower capacity cables, so-called thin cables. So they have a different viewpoint, obviously, with respect to topology and technology. So we want to get that, and we have an equipment provider. But first of all, we have Ian Clark, who's the Vice President of Global Submarine Solutions from Sienna. Alistair Wilkie, the Chief Technology Officer of Deep Blue Cable. TV Rao, who's the Senior Vice President and CTO of Tata Communications. Winston Q, who's representing PLDC and the PLCN project. And finally, Nanang Hernando from Telin. So he's going to talk about some of the new things in Indonesia. So the up-and-coming systems there. So as the fourth most populous nation in the world, they have some interesting connectivity between all the islands. So I kind of wanted to open it up. I think we'll go in series from Ian downwards to first ask the general question about what are some of the new network topologies that we should start considering, and what technologies enable them. So what new network topologies are important? So I'd like to get everybody's viewpoint first and kind of make an opening statement about their systems or what's relevant to their business.
Thank you, Steve. The main evolution in some of the technologies for the next generation networks is the evolution of the WSS Rotoms we're going to start to see on the new cable systems, and how that technology can be adapted for both thin routes in terms of being able to reduce the fiber pairs in the cables and provide some flexibility, but also in the major trunk routes and just allowing us the understanding of the adaptation of different geopolitics and the challenges we face in cables that have got a 25-year lifetime. When you couple that with the evolution of the modem technology, we're going to start to see a lot of flexibility in the networks. It's also critical to understand that some of the SLT technologies that we're seeing will also help to extend the life of the existing cables. We've got a great install base out there. Being able to reduce the cost of bandwidth by increased modem technology, cheaper wavelengths is also very critical to the industry. Thank you.
Okay. Alistair?
I'm going to slightly disagree with Ian on this one. Rotom technology is great where you've got unknowns and islands, etc., which have varying, well, they're not going to have varying populations, but where you have varying needs. If you've got an island with a fixed population, it's not going to got that much. So why have a Rotom? Rotoms themselves are just as good. And I think this is something that the network topology guys need to look at more carefully, is how you can get the thin routes working properly on the smaller islands.
I think in comment to that one, it's the combination of fixed Rotoms, flexible Rotoms, and fixed branch units. It's all of those technologies used together to architect a network at any one time.
Yeah, and I think we need to, for the thin routes, we need to make it as cheap as possible.
I think Rotoms can be used in restoration as well as just changing bandwidth needs, so they have an important role there. So good, we have some difference already.
I think probably my views are, see, what is the ultimate topology a network can have? It could be fully connected, fully meshed network. But I think that will be the costliest network one can build. Right? I think so today probably there is a tendency to kind of go towards that, but I think the cost of doing that would be prohibitively high, unless I think you have an architecture which these fully connected networks are built by different people, but they're available for sharing. I think that's one architecture which probably in a way, I think probably SD-WAN kind of technologies, which I think the terrestrial guys are trying to do now, I think would probably give way to some optimization possible. I think, in my opinion, I think that will be go-to architecture, I think, for in any, I think, links I think we're going to build.
Okay, Winston, can you tell us your viewpoint, especially with regards to your project?
Okay, thank you. So I'm Winston from the PLDC. So as many of us we know, there are many submarine cables across the Pacific. But surprisingly, you may understand there's none connecting Hong Kong and the US directly. Where there's much traffic between these two markets. So we are now planning, we are here. We partner with Facebook and Google to build the next generation submarine network directly connecting Hong Kong and the US. We have taken into several key factors of next generation submarine cable network into consideration, such as the cost, technology, and the network architecture, and also the time to enter into the market. So our network, PLCN, will feature with the next generation submarine network with several key features. First, it will be designed as an open cable. So in that case, we can not only adapt the latest technology, but it allows us to upgrade or extend the cable system in the future. We have more smoothly to do some upgrades. And on the other hand, we adopt the state-of-the-art technology, which is C plus L band technology. I think it's the first cable to use such a new technology. With C plus L technology, over 13,000 kilometers away. So it's quite the latest technology. And on the other thing is we have huge capacity. So it's a requirement for our next generation network. We have 6 fiber pair in the system. Each pair has 24 terabits bandwidth. So together we are 144 terabits together. And on the other hand, we also need to consider about the resiliency, diversity of the cable routes. So for this cable, we go across the South Pacific without stops to link Hong Kong and US directly. And also we have designed several various products to meet the new requirement from different customers. Like we have dark fiber pair, half dark fiber pair, and quarter dark fiber pair product to offer to OTT customer or key carriers. And also we have bandwidth, wavelengths, and spectrum products to offer to the carrier requirement, and also has Flexi Ethernet products. And here I'd like to share with the panel good news about our project, as we all concern the progress of PLCN. And in the last week, we got the approval from Chinese authority to go ahead with the marine survey for our PLCN cable project. We all understand it's not easy to get approval to do such a project in South Sea of China. But so with such approval, so we are confident that the project PLCN will be finished in Q4 next year. Okay, thank you.
Okay. Yeah, it's an interesting project. You know, it'll be the longest submarine system at the 13,000 plus kilometers and the first to use C plus L, as you mentioned. In terms of, say, if spectrum sharing is done in this cable, is there anybody who's ever talked about like somebody having the C band and somebody having the L band? Would you separate that as different bands or just route one whole band completely off one branch?
Yeah, there's sometimes there's concern about the power or even the performance of the C band and the L band. As we have discussed closely with our system supplier T-Subcom, the technology used in PLCN, the quality and the spectrum will quite equal for C band and L band. So it's no matter whether you use C band or L band, you will get the same performance. So in the future, when we allow allocate the spectrum to customers, we'll most likely we will allocate the continuous spectrum to a customer. Okay.
Okay. Finally, Nanang, can you tell us a little bit about new network topologies, say as they relate to Indonesia and Southeast Asia? For instance, I've heard about the interesting project called IIG, Indonesia International Gateway. So perhaps you can tell us about new systems as they relate to more to this region.
Okay, thank you. Let me introduce myself. I'm Nanang from Telkom Indonesia International. It's a business arm of Telkom Indonesia for international business. Currently, we have 9 cables globally, and the recent cables we have is CME5, connect directly from Indonesia to Europe, and CUS from Indonesia directly to LA. We have also ongoing project called IGG, actually. It's not IIG, IGG, Indonesia Global Gateway, that connects CME5 to CUS in Indonesia territory. So it's shorten the path between Europe to US directly from Singapore to LA using IGG project. The project itself, IGG, is using Rotom technology to get easier or flexible bandwidth and adding capacity. And we use also 4 fiber pair from an 80 lambda per pair, and plus also 100 gig per lambda. So the total capacity ultimately will be 32 tera. It will be ready in Q3 next year. So by IGG, we can connect directly from Europe to US. And the latency from Singapore to LA, 173 milliseconds compared to AAG, for example, is bigger. And IGG will shorten from compared to AAG. From network point of view, or topology point of view, Telin as an operator seeks for flexible and higher bandwidth capacity. Probably vendors can provide that, and also fast provisioning, because this customer need in the future that they can change the bandwidth, the capacity easily and fast, and also have high reliability for the network. So that's why we employ Rotom technology in the submarine cables. That's it.
Okay. Maybe I missed it, but how many landing points do you have proposed total in that system?
IGG itself?
Yeah.
It's 10 landing points in Jakarta, Surabaya,
Okay.
Denpasar, then in Makassar and Manado.
Okay. Okay. Yeah, okay, another question is, and again, we don't have to go sequentially, just anyone who wants to answer the question. Are there any lessons to be taken from terrestrial network architectures, especially terrestrial meshes, that we can translate to submarine networks? What are the lessons learned from terrestrial? Ian?
Yeah, there's many lessons to be learned. We talk traditionally about some of the key parameters when we're modeling submarine networks, trying to understand the capacity, which ultimately drives the cost per bit. But what we've done in terrestrial networks is try to understand how many Rotoms you can traverse, and that has an impact in that ultimate capacity statement. So as we start to knit together many systems, understanding the impairments through Rotoms is going to be a key one to learn. As we start to apply control planes for mesh networks for restoration, looking at the different potential route paths and understanding how exactly it could be switched, and making sure that any A to Z permutation is verified. So automation brings flexibility, but also there's just a second and third level of additional balances and checks to be done. It's nothing new from a terrestrial standpoint. It's just taking those lessons learned and certainly bring them into the submarine market. And quality of fiber. From the backhauls, we've gone through last 20 years of evolution in terrestrial networks, and understanding and making sure the quality of fiber in the backhauls from the cable station into the POPs is going to be very critical in ensuring that you leverage all the investment from the new builds and make sure you get the best return on that investment. Thank you.
Yeah, I think there's also a social responsibility that we have as an industry to ensure that all the people of the earth can have access to the internet. And it comes to the previous presentation about trying to get probably the unknown people in the middle of Africa and the middle of Russia, countries which don't have access to submarine cables, and also the social responsibility we have to go to the smaller islands in the Pacific, Caribbean, and other parts of the world. And that we need to be able to integrate the terrestrial, the satellite, and the submarine together into a mesh network that covers everybody.
Okay. Any other viewpoints?
I think the one lesson which probably we should see from the terrestrial kind of experience is people started building non-scalable networks, and I think every time I think a major change has to happen, it was a forklift. I think that was very very wrong thing which happened in the terrestrial things, and I think yes, that added to the investments and the things. So from at least today, one can look at a reasonable future, and I think and build a blueprint first, and then I think build the networks. I think that would be the best thing to do than kind of creep in the incrementalism, which I think probably some of the previous deployments have gone through.
Okay. Any other viewpoints, or should we go off? Okay.
Yeah, we get lesson learned from terrestrial network, because telecom also operates Rotom and OTN network in terrestrial. Some points that we should get benefit from terrestrial to submarine is that the bandwidth should be flexible. Rotom in submarine is, I would say, less flexible compared to terrestrial network. So it's not easy for me as an operator of submarine to add and drop lambdas according to customer need in a submarine compared to terrestrial. And also should be fast provisioning, fast activation of the services by using, let's say, SDN-like technology. We can easily activate services in terrestrial network compared to submarine that's not SDN ready for the technology. That's it.
Okay, thank you. So, we heard a little bit about, submarine networks to connect to underserved areas of the world. I know we as Facebook are starting to examine that, also. But, what considerations do you use, for these so-called thin cables, less capacity? Do you try to connect them to fat cables that are carrying huge amounts of information and you spin off like long, thin cables, or do you land and then just treat them as two separate cables? And are there certain topologies, say you're going down an area that's kind of has a lot of geopolitical instability? Do you just do like all branches to that point and make them flexible? So any comments about that mix?
I think there's an interesting issue here. We have big fat pipes connecting nowadays data centers, which may not actually be population centers. So there's two different things there. I think on the thin routes connecting the smaller populations, I think we need to use a combination of drops off the fat pipes, but obviously then we have to ensure that they have the backup, the restoration routes, so then we have the festoon systems connect them together. So it's a combination of the two, and a lot of it really depends on distances and what the population centers are. So it's a mixture of the two. In my part of the world, in the Caribbean, geopolitical issues aren't really a problem, but in other parts of the world, they may be.
Okay. And just to build on that, if you were looking at, say, a next generation consortia cable, understanding the bandwidth demands over the life of that cable could vary greatly based on certainly geopolitical changes. So having flexibility that a thin route today might not be a thin route in 5 years, right? It could completely change. So certainly flexibility is key. But a thin route today, 2 terabits, 3 terabits. It only takes 1 or 2 minor changes, change it to a 20 terabit demand. So making sure we have flexibility without driving extreme capex investment at the start, but monitoring and ensuring that we can drive both OpEx down and flexibility is always going to be key from our side.
Mm-hmm. Okay. Any other viewpoints? No? Okay. So the next question, I guess, is more regarding operations and maintainability. So how can new technologies or topologies and technologies help us to reduce upgrade and maintenance cycles? Like one example might be, of course, a lot of these submarine links are expensive to repair, and you may, have to sign up for, say, the gold repair service, which, guarantees fixing that within a certain time. So for instance, if you build a topology that's maybe more meshy, you don't need to have that fixed as fast. It's not as critical. So maybe you sign up for the bronze service or something, so that you have a different viewpoint as to maintainability of these cables. Any comments, or can you expand upon that thought?
I think on the long term for the maintenance, we're trying to reduce cost up front. Unfortunately, that may not actually reduce the overall cost of the system because the maintenance of the system may be more expensive. And I think this is something that we need to look at very carefully. If you reduce the type of, make cheaper cable, it may be harder to joint. And if it's harder to joint, then you have a problem with maintenance going forward. And if you accept a system of 25 years, you'd probably be paying again for the system in your maintenance costs. So you have to, yes, it might be cheaper up front, but you have higher maintenance costs. So I think we need to look very carefully at how we build the systems cheaply, but obviously get the topology correct.
Okay. I'll probably look at maintainability from a different aspect. One is, are you able to predict something which is going to happen? I think, so whether by having some probes or some kind of a data feedback, and I think based on which I think if you're able to really predict, yes, such a fault is going to happen, or such an event is going to happen, then I think that gives you a good window of opportunity for repair or restore, whatever. So I think today, with the kind of analytics being available, and I think with the huge amount of data being available of the historical data, I think that could be one aspect which I think probably which the submarine part of the industry is not actually looking at in a big way. Probably that can help in a better maintainability of the system, which can probably save a lot of, and at least prevent a lot of things which can go wrong in the maintenance. The probes part of it, I think it's again today, if you don't do it in the design, I think probably it's much difficult to do it later on. Especially with the software kind of a thing, which I think probably the box is going to be a COTS kind of a box, and I think you're going to put some software and some physical electronics there. I think on the fly doing these probes or changing the type of probes what you're going to put probably maybe much more feasible today than it was probably a few years back. I think those are some aspects I think which probably I think the manufacturers will have to consider going forward.
Okay. Some other comments, Winston?
So we are thinking about the restoration or resiliency of cable system. So as for our project, PLC, is a single linear cable, just one cable. So we are thinking about for different cable operators, we may have entered into some relation or something like to mutual restoration. So that is so as to improve the whole network availability and security. So maybe we need to have more cooperation between the operators and the cable owners. Yep, thank you.
Yeah, I would add some point that in an operation point of view, I think we have problem in upgrading systems because it takes time upgrading submarine cable compared to terrestrial cable. For example, we have recent cables upgrade. It takes about 6 to 9 months to upgrade capacity compared to terrestrial cables. So I think it's a big issue for us to serve our customer fast and secure and also flexible. That's the problem that we in the submarine community should be improve our network here to make upgrade much faster than before.
Okay. Ian, you have another comment?
From our side, cables will always break. There's, and most of the time it's through human intervention that those happen, right? So certainly education is a focus that we could spend a lot of time on. In industries, in education of the fishermen, that's nothing new. But it comes down to trade-offs. If you're going to plan a cable that is focused on latency, you're going to go more direct than what a less latency-sensitive cable could be. So does it route through an area which has got a higher risk of potential failure? So do we start to look at pricing cable maintenance based on the potential for it to fail by different events, okay? If you can start to use analytics, which are what a number of people talk about in proactive monitoring, can the analytics be used to come up with a commercial model for maintenance? Many decisions we can take based on routing or its susceptibility. Some cables have much more failures than other cables. Will we ever get to a point where you're happy to leave a cable broken to, say, pick it up and fix it at a later time, a delayed repair for a cheaper one? I think that's an interesting debate, but with the evolution of the new cables complementing some of the legacy cables today, we're at a point now if a new cable fails, how do you restore all that traffic across many other cables, I think is certainly a challenge. So would an older cable, say 15 years, carrying some small amount of bandwidth, could you look at having a delayed repair on that one? Possible. I think that the simple answer is it's called dialogue and looking at things and seeing what could be achieved.
Okay, thank you. Okay, I think we'll move on to the next question then. So we have touched a little bit on Rotoms. I know there's a difference of opinion depending upon the application. How important do you think Rotoms are to new network topologies? What can they enable, and how much granularity is needed? For instance, can we stick with the banded Rotoms, fixed Rotoms, or how much does the full WSS Rotom buy us, like in terrestrial? And in fact, a lot of these systems, as Ian, you mentioned, are connected to terrestrial networks, and they have WSSs in them as well. So can you make some comments, I guess, about Rotom technology and what's needed?
I think a lot of it comes down to the cost, and if we can, cost and reliability, we can get the cost and reliability of the wavelength selectable switch Rotoms underwater that are easily switched, then yes, they will be used more on the thin routes. However, compensating against that, current Rotom technology, the simple fixed wavelengths, then that is actually much cheaper, and we know it is very reliable. But I think it's a combination of the two. For the fat pipes, then yes, I think the wavelength selectable switches will be the way to go. But for the thin routes, I think we'll stick with the Rotoms.
I think from the evolution of the modem technology we're going through in the industry at the moment in time, the extreme change in the baud rates, going from circa 30 gigabaud at the moment in time, up to the next 2 or 3 years, you're going to see north of 70 gigabaud. Having a completely flexible Rotom which can scale the media channels for that is going to be critical. Does it apply to thin routes where you've got 1 or 2 channels maybe? Probably not as much, but the ability to scale the Rotom to adapt to the media channels is going to be critical. So having that technology is a must for me.
Yeah, that's a good point. So the channel plans you're saying will change drastically over the next couple of years, yeah, with all the different baud rate possibilities. Any other views on the importance of Rotoms and technology there?
I think the Rotom have give us the flexibility to manage the spectrum of a system. But there seems, I'm not sure whether there's any consideration during the design phase. We need to allocate a specific spectrum to each link or out or in or the job or an up. So is there any things we need to take into consideration if we use Rotom.
The traditional industry modulation schemes of QPSK, BPSK, even 16 QAM, we're going to see, I would personally suggest, a move away from referring to those modulation schemes. We're in the process of getting close on 15, 16 different modulation schemes today. So for ease of standardization, we're going to start talking about the baud rate and the throughput in terms of bits. Whatever modulation scheme it's used to achieve that, certainly with probabilistic shaping and various different techniques, is going to be so complex for us to monitor. So as an industry, we're just going to be talking about 200 gigabits at X gigabaud. So a lot of complex different modulation schemes, but it's just easy to standardize on throughput. It all comes down to spectral efficiency. That should drive the cost and be able to simplify how you're planning your wavelengths.
Okay.
Definitely, we need Rotom in the future. Currently, we also employ Rotom. Rotom gives us flexibility and more reliability to the network, and easy to operate, simple to operate, and also give faster recovery of the service. So we are looking for Rotom more flexible in the future, and like a terrestrial system that we have in submarine. Because today we have, I think, less degree compared to terrestrial network. Let's say only 2 degrees. In terrestrial network, we have at least 4 to 6 degrees Rotom. So it's more flexible to move or to reroute the lambdas compared to submarine network.
Right, right. And Rotoms, Ian, maybe you can answer this. Undersea Rotoms are traditionally starting as 1 by 2, or is there any need to go to a multi-degree undersea Rotom, similar to terrestrial ones?
Great question. I think a lot of the wet plant suppliers design the networks based on operators' demands, first of all. I think education of what can be achieved is the first step, because we still plan in a traditional manner, which is a 1 by 2, a single branch drop. And what, certainly from my knowledge of speaking with wet plant suppliers, it's ensuring that the reliability, that if something goes wrong, you can still pick the BU up if need be. So it's how you actually build the branching unit with the Rotom, and you might stack 2 together, where if one branch goes down, you can still pick it up and not affect the other one. So it's really a reliability concept to achieve a virtual multi-drop Rotom, but how you physically implement it, making sure you can pick them off the seabed if something goes wrong. So I think it's a design consideration more than a functionality consideration.
Right. Okay. Thanks. Then finally, so far the discussion's been centered around technology, physical, optical technology, but so if we implement all of these things, the network, submarine network, could become, hundreds of times more complex, right? So we have a mesh now, all these interconnected possibilities, or some degree of meshiness. Then the advanced coherent receivers, which, today, last year we had like 3 modes, and it was easy to figure, oh, that's QPSK, that's a QAM. But we could be going to like 25 modes, and who knows what the hell mode 19 is called. You no longer have a name for it. So like mode 19 is going here, but if there's a break, I'm going to restore, and I'm going to use mode 23, blah, blah, blah. So this, how are we going to handle this with software and SDN?
So the simple answer is we have to ensure that all the networks that we build across the industry are open, and that's standardized interfaces, standardized APIs, such that we can have a single provisioning platform that can deal with many different supplier-based wet plants / modems. We can only achieve that if we work together to ensure that we are standardized, and that's the APIs, and it's trying to work as a community. SDN will evolve over the next 2 or 3 years into the submarine community. There's certainly some fear factors in terms of power feed equipment, and it's more monitoring of that type of technology instead of controlling. But the ability to provision seamlessly across these networks with a control plane is an absolute must for our industry, if we're going to achieve the cost reductions the industry is demanding. And it's not just hardware, it's the operational costs, it's the simplification. So open is the only way forward.
Okay. Good answer.
I'll just echo Ian's comments. From a small provider, we need to have a system which is easy to use, easily configurable, and we can also bring in other suppliers rather than just the original supplier. We can have any supplier's cable come in and monitor and operate it with the same software platform.
Okay.
I think this is an important thing which probably we are at an inflection point in the industry where from a traditional, I think, standardized OEM-driven thing, it is moving into the open standards, and I think most of it is going to be the software-defined. But again, no disrespect, but I think there will be always a tendency to kind of still customize it, and I think still keep some hold. That has to probably change. I think the industry has to probably adapt to that. But today, I think if you really look at it from a implementation perspective, at least for the next few years, the hybrid networks are going to be there. I think managing a hybrid network in a SDN and a conventional systems, I think, would exist. That, I think, probably would pose some challenges, but I think they need to be addressed, very meticulously, because any mistake in that, I think, probably kill the upcoming technologies. That's one danger I think one has. Or it can easily skid into a kind of a standards or the previous legacy kind of a things creeping into the open standards. So that's one danger. I think we need to be cautious, and I think we need to ensure that doesn't happen. Today, if you really look at, I think especially on the transport network side, I think the physics is still important. I think end of the day, I think you still need the lasers, you need the receivers, and etc. So which I think will pose some problems, which compared to a standard, a router, or a switch, I think was probably less easier to deal with. So I think that part of it need to be done. One need to be able to get into a level where I think even a WSS, I think we are able to do at a software level in a big way. I think that probably will change the whole paradigm how the optical or this kind of a cable industry would change.
Okay.
Okay. Answer the importance of SDN is that it may enable us to deliver service faster, and also activating the service circuit or shortly. But we also know the SDN work well in case our whole network is built in a single vendor. But if there is a multiple vendor in the network, how do we use the SDN? For example, in our submarine cable systems, if there is interconnection between different systems, like if a PLCN and AAU1, how we can use the SDN to make the interconnection more smoothly is maybe we need to take into consideration. And also in case if we have need to do restoration in case of a cable cut, we need to change the channel or the cable out of our service. So how can we use SDN to make this happen more easy or far more, even more quickly? So I think we need to take it into consideration in the future for such a SDN service. And also, how can the SDN be interoperability between multiple equipment providers? Thank you.
Okay.
I think SDN is needed because it will simplify the operation, then reduce OPEX, and reduce cost of operation. But the question is when the operator implement this technology in the future, because there are still issues in SDN, such as interoperability between vendors, and then SDN technology is not mature enough, and then integration with the existing network is still a painful problem. That's it.
Yeah, okay, thank you. I think we're at a point now where we can open up for questions from the audience. You can ask either general questions to the panel or ask specific questions to one panel member. Any questions? We have one here, okay.
Thank you. I think the question is probably directed to Alistair, where, struck a chord. Those of us who work in small systems around the Pacific, particularly, the vexed question is scalability. And I think there are some other sessions that touch on this as well, again. But at the terminal end of cable systems, we see some progress, but I'm wondering, is there any hope for scalability at the both cable and more particularly the repeater level for improvements in lowering the capital cost to small nations? For example, I've recently had a supplier say, well, you've got 2 fibers, it's not going to save you any money to have one. And if that's the case, then maybe that's the way it is. But is there hope for scalability? And I don't think there are any suppliers and manufacturers of systems on the panel, but it is a question for the industry, I think.
Right.
Thank you for that. I think the question really can be answered probably better by some of the suppliers. However, there is a need for thin but sort of cheap routes which have enough capacity for some of the islands, as you mentioned, in the South Pacific, which are, their main problem is actually distance. It's I think where I am in the Caribbean, it's not distance, it's just quantity of islands. But I think there are some initiatives going ahead at the moment to particularly look after the Solomons, Fiji, and other islands which will have the connectivity. It isn't going to be easy, though, and unfortunately, it's not cheap.
Okay. Any other questions from the audience?
Thank you, Steve. Thank
Okay.
you, the panel.
Yeah, thank
let's-
the panel here for their participation.